Hello, welcome to this webinar on global supply chains in a fragmented world, ensuring access to critical materials. Can I actually give the floor to Bruno Charat, who is chair of the HLF?
Good morning or good afternoon to everyone. As chair of the high-level forum, it's my great pleasure to open this webinar and to welcome all of you who are joining us today. First, I'd like to warmly thank Richard Daischer and Marie-Pierre Versiel, the HLF team, and all the speakers for their dedication and the quality of their work in preparing this event. This webinar is indeed fully aligned with the mission of the high-level forum. And for those who don't know what high-level forum is, it's an international network of innovation ecosystems which brings together decision makers from the worlds of research and education, industry, and public authorities. And all these ecosystems are deeply engaged in the management and promotion of innovation within their regional ecosystem and often worldwide. Next slide, please. We actively prepare for our next 3 days annual summit that will be held in Grenoble early February 2026. It will be a key opportunity to deepen our exchange and continue our collective reflection on the major issues that bring us today together. If you're interested to join, please do not hesitate to contact Emma or me for more information. I wish you all a very engaging and insightful webinar, and I'm now pleased to hand over to our chairs, Richard and Marie-Pierre.
Thank you very much, Bruno. This is Richard Daischer. I direct the U.S. Asia Technology Management Center at Stanford University. I'm also privileged to be a member of the steering committee of the High Level Forum. And I will take over the panel discussion in the second half of our webinar today. For the first half, I'd like to turn the microphone over to my colleague, Marie-Pierre Ypersil from the province of Quebec. Marie-Pierre, it's yours.
Thank you, Richard. Hi, my name is Marie-Pierre Ypersil. I'm CEO of Prima Quebec, which is the Advanced Material Research and Innovation Hub based in Quebec. So today's webinar is organized as follows. First, we will have a keynote speaker, Dr. Ponceau, whom I will introduce shortly. After a few questions, I will hand over to Richard, as he just said previously, to moderate the panel, who will be composed of, switch slide, Jocelyn Douret, Director of Mining Policies, Minister of Natural Resources and Forests from the Government of Quebec, Claude Leglise, Chairman and Co-founder and Chairman of ClearSpot Holdings, and Dr. Samuel, Professor of Management at the Grenoble Institute of Technology and Management. Just a small point of logistic. At the Q&A session, please feel free to ask your question in the chat section, just to see bottom right of your screen. So now let me introduce you to Dr. Ponceau, member of the Academy of Technology since 2024. Dr. Ponceau holds a PhD in physics, material science from l'École Normale Supérieure. He worked during 25 years on nuclear fuel cycle at CEA, where he developed a wide expertise on energy. Since 2020, he is Deputy Director General of the French Geological Survey, having previously served also as its scientific director until 2024. The French Geological Survey is a research and expertise organization responsible for improving knowledge and of the subsurface, supporting related public policies and proposing solutions to challenges related to natural resources and risks. So in this context, he has played a key role in raising awareness of the importance of the subsurface in the energy transition. So Dr. Ponceau, over to you.
Thank you very much, Marie-Pierre, for this kind introduction. And I'm very pleased to have the chance to explain why and how the critical raw materials are back today on the geopolitical scene. So let me share first my presentation. Can you confirm that you see my presentation?
Yeah, perfect.
Okay. So I will, in my presentation, focus on why, how, and the critical raw materials are becoming a new challenge for the digital and energy transition. So just a few step back in the history of the last decade. Maybe some of you reminds that in 2010, we have a preliminary crisis regarding the rare earth materials, rare earth minerals, due to the tensions between China and Japan. And it was the first time, basically, in the recent years that such tension appear. So it led to a rising awareness in the Occidental countries, although there was very little action plan, I would say, regarding how to overcome such a situation. So the real tension and the real difficulties appear first because of the COVID outbreak in 2020 and the stop or slowdown of the supply chains, but more clearly in 2022 with the invasion of Ukraine by Russia, and which led to both supply crisis due to the disruption of the supply chains and also an energy crisis in many countries, which led to a slowdown of some of the production plants, which feed this supply crisis. And from that date, so in the last 3 years, it was a long-standing history of measures taken in particular by China regarding the exportation of critical raw materials. So you see here some of the measures which were taken regarding gallium, germanium, rare earths, graphite, and other elements. And it's a very regular measures which were taken in order for China to still keep its monopoly regarding these supply chains. And I will be back on that in a few minutes. And last but not least, in the last year, we also see the United States taking a rising role, a rising place in these overall pictures, in particular with the strong statement from the President Trump regarding Greenland or regarding Ukraine, and also the last deals on the rare earth between China and US. And keep also in mind that beyond this overall geopolitical world scale scene, there is also some local conflict which are fed by the question of the critical raw materials. And I just remind, for instance, the war in Kivu between Democratic Republic of Congo and Rwanda. So all this situation is related to the fact that in our societies right now, we have a rising need for critical raw materials, which is related first to the development of the countries, and in particular, the development of the infrastructures, but which is a long-standing need in the history, which is related directly to the Industrial Revolution. But more recently, we have two strong drivers which appear. First one is the energy transition, and the second is the digital transition. Both of them are occurring at the same time, and it led to a very significant increasing need for a large amount of mineral resources, of new mineral resources with a high requirement in purity. And it led to this kind of figure you see on the screen. I mean, where the world was dominated by a few metals one century ago, we roughly need currently more than 50 elements in order to manufacture all our technologies, and in particular our high-tech technologies. So just let me give you a few illustrations. So first, regarding the digital world, it's a highly intense world in terms of mineral resources. We have to keep in mind that the web, which is the basis for this digital world, is a physical network with all the cables which contain a significant amount of trace elements in order to have the relevant properties. So this network is all around the world. We have also a very significant volume of digital data which is accumulated and which is increasing very significantly and very fast. And you see that the anticipated data for 2025 is in the range of 175 zettabytes. So beyond this data, for sure, you have all the microelectronics, all the chips which are needed in order to manufacture the data centers. So it represents significant amount of mineral resources. Our current world is also a world which is dominated by connected objects. And the first of which is for sure our smartphone. And these objects are very rich in metals, and in particular in critical raw materials. So you have here an illustration of the type of metals you may find in a smartphone, but just keep in mind that in the smartphone you are using most of the time, the concentration in many of the minerals in it is higher than what we can find in the ground, even in the higher concentrated mines we are already operating. So it's a very significant resource that is needed in order to manufacture all these objects. And last but not least, if you want digital applications, you need energy in order to feed the digital network. And it represents already a significant part of the world energy consumption in the range of 5 to 10%. And it's assumed to significantly increase in the next years, as you can see on the figure here. So altogether, it means that we have a significant need for mineral resources in order to develop the high-tech digital technologies, which is one of the new drivers for this critical raw materials race. So the second driver is energy transition, and the energy transition is basically the shift from the fossil energies towards the low-carbon technologies, and this shift is related to a significant increase in terms of mineral resources need. So it's what you can see on the figure on the left, which are taken from the IEA report from 2021. If I look on the lower part of the figure, you see that in order to generate power, generate electricity, you have different available technologies. So on wind power, solar, photovoltaics, nuclear, coal, nuclear gas, natural gas. And what is presented on this figure is the content in mineral resources in terms of kilograms per megawatt of installed capacity. So first point, you see that you have a very significant difference between the historical fossil technologies and the new low carbon technologies, which are much higher in terms of mineral resources content. And just to give an illustration, if you compare a coal power plant, which is, let's keep in mind, currently the most used way of producing electricity at the world scale, with the offshore wind technology, you have 6 times higher content in mineral resources in the offshore wind technologies. And just keep in mind that it's for megawatt installed power. So you have to correct this figure by the difference in terms of availability, which is much lower for the offshore technology by comparison to the coal power, which means that at the end, if you try to compare in terms of kilograms of minerals per kilowatt hours of electricity, it's in the range of 15 to 20 in terms of difference. It's huge. It's huge, and it's exactly the same picture we have in terms of usage. It's what you can see on the upper part of the figure. You see that within an electric car, you have roughly 6 times more minerals than what you find in a conventional fossil car. And it's directly related to the battery in particular, which are highly demanding in terms of minerals resource. So when you combine everything together, you find this type of figures, which are taken from a more recent report from IEA from 2024. You see that whatever you look for, either historical metal like copper or new metal like lithium, we are expecting a significant increase in terms of consumption, in terms of need in the next 20 years. And the increase is very significant. Like, for instance, for copper, it's in the range 50% higher, but for lithium, it's 800% higher. So it's huge. And at the same time, when you see the part of these metals which going to be used for the energy, it's also increasing. For instance, for copper, it's a green part of the bars. So from 24 to 50%, and from lithium from 56 to 91%. So when you combine everything together, you see that we have really a key challenge facing all together, which is how are we able to meet this increasing demand in order to be able to sustain our digital and energy transition. And we have to keep in mind that everything is combined, is interlinked. So it's what you can see on this Mendeleev table. So I have drawn in blue every element which are needed for the energy transition, and in orange the element which are needed for the digital transition. So you see several things. First point, roughly 2/3 of the existing elements on Earth are needed in order to manufacture our high-tech technology. So it's very significant. Second, you see that roughly 2/3 of the element we need are both used for the energy and the digital transition, which means that we may have some conflict of usage to come and some concurrence that we will have to deal with. So within these elements, some of them are very critical in the sense that they can create significant risk on the economy and on the industry, and some of them are strategic in the sense they are mandatory for the sovereign national policies like defense, energy, and so on. And just to keep roughly a key image, you can keep in mind that the amount of mineral resources we need to extract from the ground by 2050 is higher than what we already extract from the ground from the Bronze Age. So it's a very significant race, a very significant revolution we have to deal with. So how can we expect or anticipate to be able to meet this demand? So you see here, I just take the very simple example of copper. So you have on the left, still taken from the IEA report, the anticipated need, the two curves, and the anticipated production with the mine in operations, darker surface, and with the mining project, the lighter one. And you see that a discrepancy is appearing by 2030, roughly, which is linked to the fact that due to investment which were not high enough, due also to the difficulty to bring new mines to the market, the production is going to slightly slow down or be stable, whereas we need to increase and whereas the need is increasing. So we can wonder whether it's related to the fact that we already take most of the copper from the ground. So it's what you can see on the figure on the right. You see that the production, which is the blue data, which is right on the right part of the figure, is in the range of 20 million tons per year, whereas the reserves, which are already known, is in the range of 800 million tons. So you clearly see here the high discrepancy between what we are producing compared to what we know is existing. And it's directly related to the fact that the question is not a question of stockpile, which will not be high enough, but a question of speed at which we success to extract this material from the ground. And one of the reasons for that, as already mentioned, is the fact that this investment is not so high, or it's already high, but it's not high enough, I would say. And it's due to the volatility of the price. You see here the evolution of the copper price on the last 50 years. And due also to the fact that the time you need to develop a mine is high, in the range of 15 years, and it's an average at the world scale. So it means that it's very difficult for an investor, a private investor, to take a huge decision of investment, which represent billions of dollars, of euro, while you have no information or no evidence about what's going to be the price and how you're going to be able to have a return on investment. Second point, so I discuss about the mine, but if you have mine, it's useless if it's alone in order to be able to manufacture your technology. So you need a full value chain, a full supply chains, which is very complex. You have here a very simple cartoon of how it looks like for lithium, which is one of the most simple case. So not only you have the extraction step, but you need also to refine and purify the lithium. You need to manufacture the precursor of the battery. You need to manufacture the battery and manufacture the electric vehicles. And something very important is all these steps are in most cases dispersed all around the world, which means that it's high logistic challenges to be able to master and to ensure the supply for a given industry. And which means also that a single problem or issue occurring somewhere on the supply chain may disturb and disrupt all your production, which is, for instance, what we realized with the COVID crisis some years ago. And you have to keep in mind, but I will be back on that China has taken a very significant role on these supply chains. Third important information, many of the metals we are using are not directly extracted from the ground for themselves because their concentration is too low. And rather, they are produced are byproducts of major metals. So it's what you can see on the figure on the left. So I'm not going to detail everything, but just keep in mind that basically the materials or the substances which are concentrated high enough in order to justify the opening of mine are the elements which are in the inner cycle. So the 12 elements on the darker blue. So they are the major elements which can support the decision of opening a mines. All the other elements are just recovered by additional separation process due to the fact they are byproducts within these major metals. And it means it has very strong consequences. Let's take an example as gallium. Gallium is used in some high-tech technology, microelectronics, optronics, and so on. It's one of the byproducts of aluminum. So it means that whatever the need of gallium for the microelectronics, the production of gallium, in fact, is going to be driven by the production of aluminum and the market of aluminum. So you have a kind of discrepancy between the drivers of the market, which is a driver of the major metals, and the need and the offer for the minor elements, which is just a byproduct. And when you have a look, one again of all the elements we need, you see on this Mendeleev table that the more red is the color, the higher is the dependency and the byproduct way of production. You see that most of the elements we are dealing with are byproducts, in fact, which means that there is a inelasticity of supply, inelasticity of market for in order to ensure their production. In this context, we have to keep in mind, in particular in France and in Europe, that although we were a very active mining countries in the 19th century, our level right now is quite low. As you can see here on this historical picture, you see that roughly now we are representing 5 to 6% of the overall mining activities, which is well below the part of the world population of world GNP of Europe. And so it means that it's related to the fact that we progressively transfer in the 20th century all this activity toward low cost and low regulation countries, with the significant consequences in terms of dependencies, in terms of ethical issues, because it also means that all the impact will transfer, in terms also of social aspect, because it means that mines is not anymore in the culture of our country, which is a real problem. At the same time, mining activities is still very active. You have here a picture from 2021, which depict all the projects worldwide, which represent more than 1,000 billion investment. And very surprisingly, you see that Western Europe and France in particular are completely out of this new game, which is for sure a real problem, and the reason why there is a strong mobilization right now in Europe and in particular in France. I will be back on that. So Europe right now is highly dependent on the critical raw material importation. You have here an overall picture from where most of the materials we are using is coming from. I'm not going to detail everything. You will see, because you will have the slides, that many countries are in kind of, maybe not monopoly, but playing a very high part of the high share of our overall supply. And we have a very specific place for sure for China. You see on the right side, which represent from which many of our materials is coming from, up to the range of 100% for the rare earth, for instance. So this position of China is not due neither to the concentration of the mineral resources in the ground on Chinese subsurface, neither to the fact that China has been given many minerals by chance. It's directly related to the strong Chinese policy in the last 40 years, which invest a lot in the transformation and refining technologies. So it's what you see on this figure here. You see that the geological reserves for some of the critical raw materials is not so high in the Chinese underground, except maybe for rare earths. But you see that for the extraction activities, the picture is quite different. So it means that even if they do not have a very significant amount in their underground, they operate mines in order to valorize it. And most important, you see that the processing activity is much higher. So it means that even if they have no resource in the ground, in the underground, they decided to invest in order to relocate the transformation and refining technology in China. And they have right now a position of monopoly for many of these minerals, which means that they can, at the end, decide more over what is how the market is going to behave. And it also explains why China is investing a lot worldwide in the mining activities in order to feed this processing activity, in order to feed their industry. And it's basically made through the Belt and Road initiatives. And you have here a map, for instance, of the Chinese investment in the mining sectors in Africa in 2021. The overall amount of money is huge. So which solutions do we have to increase our mineral sovereignty in Europe and France, and how do we proceed? So first, we have a new act which has been voted at European level. There's a Critical Raw Material Act, which implies a lot of things, including a new exploration programs. But I will just focus on one point, which is important. It gives a target in terms of independency for Europe, for the extraction, the processing, the recycling. And you see with figures of 10% for extraction, 40% for processing, 25% for recycling. And it also decided that we should not depend more than 65% from a single country. And you see from what I presented before that we have a very significant effort in order to reach this level. Regarding France, we have from 2022 an ambitious policy in order to secure our critical raw material supply. First, we develop and create an observatory in order to have a very clear picture about all these supply chains, which are quite complex. The name of this observatory is of Remy. Second, we develop some industry in order to valorize what is already available in our country in terms of end-of-life products, so by recycling, in terms of former mine sites also. And you have just here a picture of a new refining plant for heavy rare earths, which is under construction in southern part of France. But you have to keep in mind that whatever you do, recycling will never meet the demand, except if you have in very strong if you have a transition to occur. So it means that the third line is that we need to valorize what is available in the underground, and we are developing a new exploration program in France, which is very ambitious, with funding which is higher than 60 million. And last but not least, we will not find, and it's not our objective to be fully independent in Europe, but it means that therefore we need also to develop some strategic partnership with many countries in order to have, through diplomacy and through long-term offtake, the possibility to secure our supply. And last but not least, I will not detail, but there was also a creation of some dedicated investment fund and an interministerial delegation in order to coordinate all this policy. Just before to conclude, to say, and it's a very important point, that for sure our aim is not to open mines as they were in the past. I mean, with a high environmental and social impact. So we aim to have what we call sustainable or responsible mining activities. So with low environmental impact. So it deals with CO2 emissions, but also with water recycling, reduction of chemicals, reduction of waste, recycling, and so on. And we also have to be able to associate the local population in order to increase the confidence, the awareness, and the acceptability of the local population with such activity, in a context that I remind you that mine is not anymore in the culture in France. So we need to rebuild such a culture. We need to rebuild the mining sectors. And so we are developing, and we are also fully involved at the international scale, some new standards in order to be able to define what is this responsible mining, and to have possibility to have external audit in order to confirm that the new mining activities will meet this demanding objective. So as a conclusion, you understand that both low carbon technologies and digital technologies significantly increase the need for mineral resources. So we are transitioning from a dependence to fossil energies in the last decades to a new dependence to mineral resources. and therefore we have to new geopolitics which appear at the world scale, as you probably realize. Despite the existing resources, which are still significant, the market and the companies will have difficulties in the next years to meet in due time the rapidly increasing demand, which means that we have to anticipate some durable tensions, and which means also that the mineral resources are weaponized. There is a weaponization of the mineral resources, which are now used for geopolitical issues, geopolitical objectives, which means therefore that we will probably have to adapt and diversify our trajectories. And Europe and France realize their strong dependence and know they are investing a lot in order to develop new technologies, to develop new industry, in particular for the recycling, to redevelop mining sectors. And last but not least, this question of the social acceptability is a major issue. And in particular, in our country where subsurface is not known at all, and we need really to be able to reintroduce the subsurface in the political and public debate, which is a very demanding objective on which we are also focusing our effort. So I thank you for your attention, and I'm for sure open to any questions, and I'm going to close the sharing of the screen to be able to see you.
Thank you very much, Dr. Poinceau, for this most informative presentation. If I may, just before starting the Q&A section, you rightly pointed out the importance of valorizing available resources and securing supply. Very broad question. How could international collaboration through innovation play a role in this regard? And considering also the targets that you mentioned from the EU Critical Raw Material Act.
Yeah, it's a very good point. In fact, the question of the critical raw material supply is not only a national question, it's an international question, and that's an international market. So it means that there is a very strong interest to share the effort with countries having the same position and the same objectives, and in particular regarding the development of innovative technologies. Just taking an example, developing responsible mining means that we need to develop a new way of operating mines in terms of chemical processes, in terms of how you crush the rocks and so on. It's no sense to develop alone for each country such a technology, and for sure we need to share the effort, and that's the reason why we are developing in France, but also in many other countries, some tight collaboration with other countries. And right now that's the reason, for instance, why I'm in Oslo in Norway in order to discuss my Norwegian colleagues.
Excellent. There's a question from the audience, well, specifically from Richard. Can the EU meet the targets for critical raw materials sovereignty in the new EU Critical Raw Materials Act?
So, as you realize, the target is an overall global numbers, and for sure the situation is very different from one minerals to the others. I mean, for some minerals, we're already over the target. For instance, let's take hafnium. Hafnium, roughly 2/3 of hafnium supply for Europe is coming from France. So we're already fully independent, or at least at a level of independence, which is well sufficient. For others, it will take years, if it's not decades, because it takes quite a long time to develop new mines. I already mentioned that point. But even constructing new plants and developing new processes is not it's not a question of months, it's a question of years, and it's a question of billions of euros to put on the table. So depending on which mineral, which substances we are discussing, the time we will reach the target will be different. And it's a very ambitious objective, I fully agree.
Thank you. There's another question from Karine. Do byproducts impair the production of the primary minerals, and does twice as much need to be extracted to obtain them?
Now, the reason why it's a byproduct is because the concentration is too low to justify a huge investment in order to develop a mine. But so it means the market price of the byproduct will have to be so high in order to justify a new mine that it will never occur. But as soon as you have a mine which is already existing for aluminum, for instance, I'm just taking back to my previous example. In many cases right now, it's worth to spend hundreds of thousands of dollars or hundred of millions of dollars to build the additional plant which is needed in order to extract the byproduct. And but you need to ensure that this investment is realized. Otherwise, you will not get this byproduct back.
Okay, thank you. There's another question. What is the EU's position on the role of recycling as a means to reduce the Union's dependence on critical raw materials? What are the programs and policies that have been implemented in this regard?
That's a very good point, because many of the people who are against mining activities are thinking that recycling may be the solution. And it's a kind of dream. I mean, for sure, we have to recycle, because recycling means that we are reusing materials which are already extracted from the ground, and it has many interests, and it's something which needs to be developed. The difficulty is, first, that it's in many cases not cheaper. So it may even be more expensive. So it means that you need to find an economic way in order to favor the recycling materials by comparison to the primary materials. Second, you have also to keep in mind that whatever you do, and even if you are very efficient, you will never be able to recover 100% of what was initially introduced in your market, in your materials, because of the dispersion, because some usage are highly dispersive, because it's highly diluted, and so on, and because of physics, because due to the secondary law of thermodynamics, you're not able to recover 100%. So it means that if you only rely on recycling, it means that you have in a situation where the industry or the technology will have to decrease very significantly. So in a situation even of a sustainable state, or a slight increase, or more importantly, in the current situation of transition, energy transition and digital transition, you need additional resources coming from the ground.
Yes.
No other way, whatever you do.
Thank you very much, Dr. Poinceau. And I will pass over to my colleague, Richard, for the second part of the webinar. Thank you.
Thank you very much, Marie-Pierre. And thank you, Dr. Poinceau, for a really informative keynote presentation. For the discussion session of our program, we have three experts. Mr. Jocelyn Douaret, who is holding three positions at present. He's the Director General of Mining Policy and Development, and also a board member of the National Mining Institute for the province of Quebec. He's also a board member of the mining industry sectoral workforce. And previously, he was with the private sector, directing the marketing office of Plan Nord Corporation. Our next person is Monsieur Claude Leglis, who is chairman and co-founder of ClearSpot Holdings, which is a solar electricity services company that serves large-scale commercial power. He has co-founded the Silicon Valley Asia Innovation Institute and also the Qingdao Innovation Institute in China. He's taught innovation management at Stanford, at the China Academy of Sciences, and at other universities. He held marketing positions and general management positions at Intel Corporation for quite some time. And our third panelist is Professor Karine Samuel, who is Professor of Management at Grenoble Institute of Technology. She's also a researcher at the Center for Applied Management Studies and Research. Her field is strategic business management and supply chain management. And she approaches her work from the crossroads of three different areas: management science, and also industrial engineering and material science. Since 2018, she's been the president of the International Association for Research in Logistics and Supply Chain Management, director of France. I'd like to ask each of our panelists to give brief prepared remarks, and then we'll have a general discussion. I'd like to go in order of Dr. Samuel first. Let her give the kind of systematic overview of what's happening in the supply chain world, then ask Monsieur Douaret to speak and give kind of critical materials in Quebec as a case study of public sector response, and finally ask Claude Leglise to speak on kind of the industry response to this situation. So, Dr. Samuel, I'd like to turn the floor over to you. Please, for audience members, put your questions in chat. We'll get to as many of them as we can.
Thank you very much, Richard, for the introduction, and hello to everyone who is attending to this webinar. So my point here is to just put the context of supply chains. I put in an uncertain world, but maybe I should have written an unknown world, because so the uncertainty has never been so high. And managing supply chains in 2025 is especially very, very complex situation now. So the global context, you can see here the top 5 supply chain risks in 2025, according to the Global Supply Chain Council. You see that, of course, all these risks are not linked to critical material, critical resources, but you see that this risk arise at number 4 in the ranking, so it's rather high in the agenda. And of course you find at the top of the ranking the climate change, the geopolitical instability, cybersecurity threats, and at least reputational risk. But if you deep into these structural risks for all industries, you see that all these risks, the top 5, are interconnected. The first challenge is, of course, for companies to move from a reactive position. That means be able to treat an issue when it appears, a supply disruption, for example, and to have some tools that help them to have alert capacities to be able to better anticipate these risks. If they do not, of course, are able to anticipate these risks, then they will be highly exposed to disruption. And of course, these disruption are causing high costs, because the cost of emergency, of course, is always very important for companies. The second challenge, of course, is to be able to anticipate technological market development, to assess criticality, because assessing material criticality is a huge task. It's not easy, as Dr. Poinceau said. It takes at least 15 years to open a mine. So when you decide to open a mine, you have to be sure that once the mine will be open, then the technology has not just jumped to another technological situation, and then that the material you just decided to mine for is not necessary again. So this is a huge risk. I mean, a long-term risk that has to be mastered. And of course, it's not at the company level that you can master this kind of risk. So risk management has become an essential activity for companies. All big companies now are general managers that are dedicated to risk, to resilience, but it's a costly and rather inefficient activity, which is generating new needs. So if we focus on critical materials, there are 3 particularities to this kind of risks that have to be mastered by companies. First is that the flows are complex and you lack visibility in the upstream supply chains. The companies are used to deal with their tier 1, tier 2 suppliers. But when you are talking about tier 5, tier 6 suppliers, then they have no visibility about what's happening. So of course, they know, because the recent decision that have been made, like in countries like China, for example, regarding rare earths, and the export controls that the Chinese have decided very recently in this year, of course, makes this kind of situation very present for companies, because they realize that even if they don't know about the tier N or regarding the raw material, then they have to be prepared that there are some disruption or new regulation that appears that they have to deal with. So complex flow, lack of visibility. And the last one is the ineffectiveness of traditional forecasting model. So how to forecast when you have no ID? We saw this improving demand, this increasing demand for many materials. Of course, this question is very important, because that means that you have to be in a situation, and each industry has a specific situation, and each company in this industry has a specific situation. So the notion of risk is really specific to a company and then to an industry. But of course, the global forecasting model that are especially the critical list of raw material, the list for critical materials that are elaborated by the US or by the European Commission, have to be adapted to the situation of each partner of the supply chain, so each company, and it's of course very complex to do that. The last point regarding supply chains is that the issues, the risk are throughout the supply chain. So we talked about geological resources. So we know where the mines, the current mines, we know where they are. But after the mines, after mining, after extracting the resource, then you need to treat the resource. And most often, the main issues are not in the mining stages of the process, but you find the main issues in the refining, the purification stage, where some countries have built a supremacy, a monopoly in this kind of industries. Especially if we look at rare earth, heavy rare earths were mastered by the Chinese, most only at 99%. So they completely block the market and have the total monopoly of the companies who are able to refine. Now the trend is to put this activity in other countries like Birmania, for example, because it's a highly polluting activity. But in the situation of the supply chain, when you need this kind of stages, for example, to build any electric component that you need in any car or any plane or any whatever you are building now as an electronic component, then you need this stage in the value chain. And of course, another thing is that we talked also about recycling. Recycling is also a critical process, because if you look at recycling means another industrial process to get back the materials. But to do that, then you need again water, you need again energy, you need again chemicals to obtain. So if you look at silver recycling, for example, the process to get back with silver from products that contain silver is almost the same process to get the silver from the ore, from the original mine. So this is also something that has to be studied and evaluated very deeply. So how to deal with uncertainty and dependency in the upstream supply chain? My work is mainly working on developing resilience capacities. What does it mean, resilience capacities? That it means that the company is able to be aware about its vulnerabilities, because the worst situation is when the vulnerabilities are unperceived by the company. So, and then be able to build reactive capacities, means able to react to a shock, react to a disruption, but also configurative capacity. That means that you are able to design your supply chain and make sure that your supply chain is adaptive enough So build your supply chain as an adaptative network that will be able to resist to any kind of disruption. And of course, the last type of capabilities are proactive capabilities. That means that you are able to anticipate, to see what will happen and to prepare to any event. So that means to have some tools like control towers or other tools that will help you to make sure that your decision will be highlighted by information that you need to be prepared to any kind of shock. To do that, my point is that companies need to, that cannot be done at a single level. So you need to have a multi-level analysis, and the resilience is not a company affair, it's an inter-organizational affair. So that means that the resilience for a dedicated industry, if you think about microelectronics, then you realize that the microelectronics it's a mix between techno diplomacy and, of course, between company resilience that each company has to build its resilience, but also need to discuss with the other company in the same industry, and is to discuss with at the political level, because there are some decisions that can be taken at the political level that influence a lot the supply chain. So this is something that is rather new. This multi-level analysis, but that is necessary to address this issue of resilience of supply chain dependent to critical materials. And of course, this is something that we do. So I am working currently on a share, which is called Scanner, which is designed as a club of industrial working in this share. So a cross-industry living lab where the solution is not only at the industrial level in the same industry, but I think that the solution also can be found in the inter-industry level. So that some issues that are encountered by the company in the automotive industry can be maybe discussed with companies from the aeronautic industry or the defense industry, and that there is this cross industry discussion that also needs to be feeded to find solutions. So this is the way I am organizing my research work and working to improve this inter-organizational resilience, linking organization, industries, and political decision making. Thank you very much.
Thank you so much, Karen. And we will keep moving on with our prepared remarks so that we have time for a couple of questions at the end. Next, I'd like to ask Jocelyne to talk about how the province of Quebec is approaching the critical minerals situation.
Yes, thank you, Richard, and thank you for inviting us. So yes, I will talk about what we did in Quebec to ensure the critical mineral supply. First of all, just to remind you that in Canada, provinces such as us have the ultimate jurisdiction over natural resources. We have our own Mining Act. Within the last, I would say, 150 years, we had activities, mining activities in Quebec continuously with no interruption. And we presently have producing mines, mostly for gold, iron, zinc, copper. I won't list them all, but one of our advantage also is to have green energy, to provide energy to those mines. That's something which is interesting in terms of carbon footprint. Back in 2019, we've seen that there was a trend. What was anticipated, the increase and the increased demand for some specific minerals, and you mentioned it before. We were talking about mostly lithium, graphite, and the others. And at the same time, we realized that Quebec had the potential to produce or was already producing some of those critical minerals. So we had the idea there was an opportunity to seize for Quebec to be a provider, and not just a provider, but also to take advantage of the situation to develop new industries and new supply chains. That's why we prepared what we call the Quebec Plan for the Development of Critical and Strategic Minerals that was active within the last 5 years. It was the first plan in Canada. So what we did, we knew that to develop such a more activities into the mining sector, new supply chains, we had to discuss with other stakeholders. And when I say other stakeholders, that means, of course, government, but also local municipalities, First Nations, universities, and of course, the industry. So we did some consultations with all of the stakeholders to see what we should do and how we should do it to develop that specific sector and take advantage of a situation. We have a, I would say, geology which is really interesting, and we also know how to mine and now how to develop that specific sector. And first of all, we discovered that we knew we didn't know in terms of critical minerals. We had some, but how to extract, how to transform, we had to work on it. And as it was mentioned previously, processes were mastered mostly by one or two countries, and especially China. So we had to redevelop our knowledge in terms of processing, concentrating, and transforming those specific critical minerals. So we had the strong efforts to do in terms of innovation, and that's why we worked with our ecosystem, innovation ecosystem in Quebec, such as with Prima, with the FRQ, which is the Research Fund of Quebec, and some other institutions. So first of all, we had to work on knowledge. We had to work on how to develop a supply chain. And of course, circular economy was key. When we did the consultations, it was clear and obvious that circular economy should be part of our policies and strategy. And as you see, that's the way we see a critical and strategic mineral value chain, because we integrate circular economy from the beginning. Even if we have, I would say, a lot of raw materials to exploit, the idea was to not to waste any of those materials, even if we had some and a lot in the soil. Of course, it was also mentioned in the other presentations, social acceptability is key. Even if Quebec is a mining jurisdiction, we still have to work with local communities, with First Nations, to make sure they will take part of those specific development, mining especially. And so we put a lot of efforts into raising awareness of population and general population regarding critical minerals and the mining, and also the necessity we have to develop mines, even if we do also efforts to integrate circular economy into our economies. And it was mentioned also, we need a lot of money to develop projects. As you've seen, usually now a project is close to 1 billion, more or less. And if you had some transformation and processing, and then you had another 1 billion. So the idea was to promote the potential and to develop relationships with other governments, because as you've seen, governments are now key into development of critical minerals. So we had what we call the mineral diplomacy, and we developed some relationships with some countries such as France. We signed an agreement in 2023. With Netherlands, we signed an agreement in 2025. So the idea was to work with other countries to help us develop the supply chains and to develop strategic partnerships with governments and industries in Europe, for example, to make sure we will find some customers for the project, for the product we will produce in Quebec, raw materials, but also transform product to create also wealth in Quebec and supply other countries. So that's what we did. So to de-risk the projects, because as we've seen, processes are not well known. Also, we have to work with the environmental regulations. We do not want to reduce the expectations in terms of environmental regulations, but we have to be more efficient. Also, the idea was to de-risk the market as much as we could. So that's why we developed relationships. And as it costs a lot of money, we put in place tax incentives. We also helped a lot with innovation, R&D, and most of our budget was dedicated to support process development. That said, after 5 years, here are the results. In terms of mining projects, in 2019, we had 23 projects active in the province of Quebec. That means projects that were beyond the level of PEA, the preliminary economical assessment. And in 2025, we reached the number of 54. That's an increase by 134%. In terms of mining investment globally, in 2019, we were around 3 billion Canadian dollars, and now we are beyond 6 billion. So that's a huge increase as well. And in terms of specifically critical and strategic minerals, exploration and project development, in 2019, it was $141 million that were spent specifically to critical minerals. In 2024, it was $532 million. That's an increase by 274%. So I believe that what we put in place finally worked, and it gave a chance to our mining projects to develop. Presently, we have 21 mining mines in operations, and 9 of them are producing critical minerals such as graphite, nickel, lithium, and we also developed some production of scandium from the waste of a Rio Tinto processing facility that was processing titanium. So scandium is now produced in Quebec because we invested also into waste processing to recover specifically scandium. We also, as a government, subsidized the project to produce gallium from aluminum production. So now we also produce gallium in Quebec. So at the end of the day, what we put in place as policies to support investment by tax incentive, to reach out investors and strategic partners, and of course to innovate. So now we are the first producer of high purity scandium oxide in North America, the only one. We were and we're still the #1 producer of niobium, #1 and only producers of graphite in Canada. And in Quebec, due to the geology we didn't choose, it comes with the earth. We have more than 50% of lithium projects in Canada. So we were fortunate enough to have a favorable geology, and now we're able to exploit the geology we have because of the policies and the investments we put into with specific sectors. Just also to say that in Quebec, we have what we call the Quebec Inc., which is mostly Investissement Québec, Investment Québec, which is the financial arm of the Quebec government, which is able to invest directly into projects to share the risk with promoters and investors throughout the chains, the supply chains. And we have $1.5 billion to help with those investments. Also, as Quebec is quite huge in terms of territory, it's 3 times the size of France. You can imagine in the northern part, we have to develop some infrastructures. And for those purpose, we have the Plan Nord and the Plan Nord Fund, which can invest as much as $2 billion in terms of infrastructure development in the future, and since today, of course. So that's what we did in terms of interventions as a government Quebec to make it happen. and to be today seen as a global supplier for critical and strategic minerals, mostly working with Europe today and Japan and South Korea. So we're now integrated into supply chains. And of course, the race to critical minerals is not finished yet, of course. And with the geopolitical context we have today, we're developing our new strategy for the next 5 years. So that's what we did, and that's what we will do. Thank you again.
Thank you very much, Jocelyn. A great case study for what Quebec is doing to respond to the new needs of critical materials and supply chains. For the last set of comments, I'd like to ask Dr. Claude Leglise to give us some ideas.
Thanks, Richard. I wrote this title slide before I heard my partners in crime speeches this morning, and I think this is it. You know, as an industrial manager, geopolitics are completely outside my control. So what do we do? And that's what I would like to give you some thoughts about. When I started my career in the computer industry 40 years ago, second and third sourcing were the standard. That's what everybody did. But by 2000 or so, the whole industry had evolved to a model of single sourcing and just-in-time delivery of materials, piece parts, etc. Not just the high-tech industry, but the same appeared in across industries, car industry, pharmaceuticals, etc., etc. And I think it's fair to say that until about 10 years ago, none of the considerations we've heard about this morning were on the radar of senior executives. But today, resilience is job one, because so many people have lost so much production because they could not get access to materials or systems. So we are moving from a system of just in time to a system of just in case. And if you look at the example of the Ford Motor Company in Q1 of 2022, so 3 years ago, they lost $3.1 billion due to semiconductor shortages. Now they have 50 to 60 days of inventory of parts, and they're held not in a central location, but in each individual country where they have an assembly plant. So they're holding the inventory next to the factory, and they've built a huge buffer. This is a major, major change, again, compared to 10 years ago. But it's a kind of action that we can take and try to absorb some of the short-term shocks in the supply chain. We've heard already this morning from Dr. Poinceau and others that building these mines takes a long time and costs a lot of money. And one of the challenges is, how do we have a business plan that makes sense economically to create a new supplier? And let me illustrate the size of the problem. In 2023, a ton of lithium carbonate sold for $70,000. Last month, it sold for less than $10,000. So if you built a business plan on the basis of $70K per ton, and now it's less than 10, your entire business falls apart. So what we're saying is a number of efforts to strengthen the suppliers by giving them a predictable business. There's a company here in California called MP Materials. It used to be Mountain Pass. A long time ago was the largest supplier of rare earth in the world. And they stopped mining about 15 years ago. So they now have two agreements, one with Apple to purchase $500 million of recycled magnets, and one with the Department of Defense to guarantee a floor price for their products for 10 years. So with those two agreements, and they have others, but with those two anchor agreements, they now can build a business plan that makes sense and that can attract capital. Same thing, there's a company in Canada by the name of Neo Performance Materials that is opening a rare earth magnet production facility in Estonia but it's backed by purchase contracts from both Bosch and Schaeffler in Germany. So again, it's a predictable business plan. If you expand that thinking beyond materials, AMD has a partnership with OpenAI to build what's known as 6 gigawatt of AI compute servers. Think of it as intelligence factories. It is backed up with a contract and a equity relationship. So this is an important element of the strategy of companies to strengthen their suppliers. Of course, every problem is an opportunity, and therefore we can innovate. And there's a lot of things going on. I picked a few examples to illustrate the topic, but there's a company here in the US called Niron Magnetics, or it's actually no iron if you think about it. They're building permanent magnets without rare earth. So they're trying to get rid of those critical elements and see if they can achieve a proper cost performance point to replace these materials. It's an important direction, and you can see GM and Stellantis are both investors in this startup. Everybody talks about AI, machine learning. Johnson & Johnson has actually deployed a really sophisticated system. They're able to monitor 27,000 suppliers. So Karine mentioned earlier, tier 1, 2, 3, 4, 5, 6, 7, they're actually monitoring all the way down the supply chain. And last year, they estimated that the system provided early warning of 85% of disruptions on average 7 days before any kind of visible effect. So they were able to get the warning and take action before they actually saw some negative consequences. The third vector, and this Raymath is a small company, about $100 million company in Ohio, that used to buy a lot of things from China and other parts of the world. And what they've embarked on is a strategy of reshoring, bringing the manufacturing back to the US. And they're making this possible by using collaborative robots. Those are robots that can sit on the factory floor along with people. So they're not going to move their arm rapidly and kill the workers. They're working in collaboration with the workers. That has changed their business. Now their business is focused on very fast turnaround for their customers. That's what they're selling is we can turn around very, very fast because we're building locally. And they have seen absolutely enormous improvements in productivity to the point where their business is growing and they're now hiring more people. So those are all different vectors, different directions, but innovation and technology investments can make really quite a big a difference. And then the last thing is there are new opportunities created by this geopolitical nightmare. One is regionalization. Exosense is a French company that has been making night vision goggles for a number of years. But now with the situation in Ukraine and the increased budget for defense in Europe, they have this huge opportunity in front of them that they are trying to take advantage of. And as you all know, the European defense budget is focused on spending money in Europe, not elsewhere. And so for a company like that, this is an opportunity. The number one producer of drones for agriculture in the US is DJI, a Chinese company. And they are now subject to tariffs and import regulations and fears that the Communist Party is downloading the data from Beijing, So Exide, which is a Japanese company, is actually now starting to design and manufacture drones for agriculture in the United States. So it is a regionalization effort. As far as technologies, there are new opportunities. Again, Will IoT out of Israel has built a system of sensors and software to monitor essentially anything for real-time visibility. And Walmart has announced they're going to deploy 90 million sensors nationwide. next year. And what it allows them to do is to know real time, instantaneously, where is every case of beer, every plastic toilet seat in their entire network. As soon as it enters their network, they can track where it is. There are also opportunities for products. There's a company called Hive in Norway that is building a series of automated material handling systems using AI and robotics. Imagine forklifts or cranes that are completely automated. Zelos in China is one of my favorite. They are doing, like the Starbucks type coffee shops, they need new coffee and new coffee cups every night, right? To restock. So this company has built a sort of autonomous vehicle for delivering goods in the middle of the night. So it's low speed, it's a predefined route, but again, it's an opportunity to impact the supply chain with new technologies. So this is probably my favorite. Is again, every problem is an opportunity to innovate. So I guess my point is the supply chain reengineering is possible. The downside is it takes time, it costs money, and it's definitely not as efficient as if we could buy anything we wanted from anywhere in the world. But at the end of the day, I don't believe we have a choice. So we can go and do things. Thank you.
Thank you very much, Claude. I know that we've reached the time for the ending of the program, and I think that our panelists have given us a wonderfully well-balanced view of the current situation with critical materials and supply chains. If I can just ask a real quick question to Karen and maybe to Claude, how do you see the role of underwater mining or underwater collection of materials from the seabed? Is that still way in the future? Can it be scaled up? Karen?
Yeah, it's a very hard question because, of course, as you can imagine, the cost of such mining is very high, and also the consequences on the seas, on the the balance between the all the animals you have in the seas and the risk associated. So this is something that we know because we explored oil under the sea, and this is not something really new. But by experience, we know that the most complex is the mine, the most costly it is, and the most, of course, externalities you may have and you may have to deal with in terms of additional costs. So yes, of course, you have the under the water mines, but you have also all the questions regarding the melting of the poles. And the way we can access to new materials in the Groenland or in other places in the planet where up to now it's not possible, but maybe in some years, we don't know how many years, but in some years we will have this access. So, but here again, it's a geopolitical issue. And the question is who belongs the mine, who is under the sea when it's there are some possessions or not, or who belongs the sea. So
yeah,
this is
that's an excellent.
My answer.
We have a new set of geopolitical tensions coming up in that regard. So I want to thank everyone,
definitely.
Jocelyn, Claude, Karen, also Dr. Poinceau, Marie-Pierre. It has been wonderful to cooperate with you. I'd like to turn the program over to Bruno for a word about our summit in February in Grenoble.
Thanks, Richard. So as I mentioned at the beginning of the webinar, we are organizing a summit, an invitation-only summit that will be held in Grenoble early February. And everything we discussed today will be discussed and deepened again during the summit. So if some of you are interested, please do not hesitate to contact Richard, Marie-Pierre, Emma, or me, so that we can give you more information about this summit and see how you could join us in this reflection on what's the place of innovation in a world of great change. Because at the main topics of this summit, clearly the world is changing. For a long time, we were speaking about a certainty. Now we are moving into a more unknown situation, and we need to rethink the place of supply chain and how to build a strong supply chain. We need to think that could be the disruption created by technology. We need to think what kind of innovation tools are available for this world of great change. So that's some of the topics that will be discussed in this summit. So if you're interested, please do not hesitate to contact us so that we can provide you more information about this summit.
Thank you, and thanks everyone for participating in our program this morning. We hope to keep in touch, and we hope to involve you again in our program soon. I will take the role of signing off for everyone here. Thanks. We will see you soon, I hope.
Thank you, everyone.
Thanks, Marie-Henri. Ciao.
Thank you.
Thank you, everybody. Thank you.
Thank you. Bye-bye.
Bye-bye.